Hi everyone, welcome back to my channel. In today's video, we'll be seeing what are asset properties and why are they important in a database. So let's start. So to begin with, asset properties, asset stands for atomicity, consistency, isolation, and durability. Asset properties are a set of principles that ensure reliable processing of database transactions. So they make sure that there are no errors and there is a transaction that is smoothly happening in a database. Now, coming to atomicity. What is atomicity? Atomicity is nothing but either a transaction which is started in a database is completely executed or the transaction is not even started. Like it's everything or nothing. Like all the operations within a transaction are performed or the transaction is not even started, like not even committed. Like if, for example, say if there is any power outage or if there is any internet connection issue, the transaction which is started is rolled back to the initial state. That transaction is not committed. So let's see this example. So in this example, you can see there are two bank accounts, say a person A and person B. Now a person A wants to transfer some money to person B. Say here the account has $30 before the transaction, and he wants to send $10 to person B. So once the transaction is started, and there is say some error due to some power outage or something. Due to that, the transaction is not processed. So what happens here is the transaction is rolled back, and it is again credited back to person's A account. Like it is not credited to person B's account. You can see that here $10 got debited and the credit amount should be $10, but the available balance after the transaction is 100. It's because there is a credit failure and the transaction is not committed. So there is no partial transactions in atomicity. This is not an atomic transaction. So let's see what is an atomic transaction. The transaction process is smoothly completed, like the amount is debited from person's A account and it is transferred successfully to person's B account. So here you can see the amount before the transaction was 100 and after the amount got credited, the available balance is $110. Moving on to consistency. Consistency is nothing but in a database, the transactions are performed, right? So when a transaction is performed, the database moves from one state to another. And the transaction must make sure that it is following to all the rules and all the constraints within a database, and it should follow the data integrity. Yeah. So consistency states that once a transaction is performed in a database, the total sum of account balances should be same before and after the transaction. Now see here that the total balance is $300, right? And at the end, the account balance is 230 from A. So now add the sum of all the accounts. So here it is $300 and here it is 100 and here it is 50. So the total sum is $450. Now let's count the account balances after the transaction. Now the final balance here is $230. So once the transactions are performed, here the account balance is 150 and here it is 70. So 230 plus 150 is 330, 370, and 70 plus 70 is 450. So you can see that the sum of account balances are same. By this, we can say that the transactions are committed properly without any errors. So this makes sure that the database is following proper consistency while performing a transaction. Okay. Now let's say there are three bank accounts, A, B, C. So B and C are requesting money from A. Now you can see that B is accessing, say, $50. A is sending $50 to account B. Now you can see that first this transaction is performed from A to B. Now initially B reads the balance of A, that is $300, and it requests $50, right? So now similarly C is also requesting money from A. And you can see that value read by C is $250. It's because first the transaction is started from B. Once the $50 is debited from account A, the final balance is $250. Account C should make sure that it is reading the updated balance, that is $250, instead of reading the uh, initial balance, that is $300. Now, coming to isolation, isolation ensures that multiple transactions can concurrently occur within a database, and the intermediate state of each transaction is unknown. Like, okay. Each transaction must be isolated with all the other transactions, and isolation property makes sure that they are not interfered with each other and the transaction data is invisible. Let's see this with an example. So here you can see that two users are simultaneously withdrawing from the same account, and each transaction should operate as if it was only one so that it prevents inconsistent data. So you can see that the value read by B before transaction 1 was $100 and the value read by C before the transaction 2 was $80. So initially the account balance was 100 and in the first transaction when the account B is accessing from A, it sees that the account balance is 100 and this $100, like this initial account balance and that data is not known by the account C. So C is also performing a transaction from A. And when the account C is accessing account A, it can see that the balance is $80. So in isolation, what happens is the transactions are scheduled one after the other. So that makes sure that the data is not inconsistent and the data is not mismatched. Now coming to durability, the last property. So durability states that once a transaction is committed, the changes are permanent. It means that if you perform a transaction and it is committed, you can't undo the transaction back. And it also makes sure that if there is any system failure or system crashes or power outages, the transactions that you perform are securely stored in a file storage or say in a hard disk. So once you reboot your system and retrieve your system back, you can see all your transactions that are performed. Like the transactions are not lost and they're securely stored in some file storage or say any hard disk. Now coming to this example, you can simply says that if there is any system crash or something like that while performing a transaction, the confirmation receipt of your transaction should be available even after you retrieve back your system. So once you restart your system back, this property ensures that the transactions that are performed by you are safely secured and they are available to retrieve. These are the four important properties that a database must adhere to while performing any transaction in a database. So that's it for the video. In the next video, I'll be explaining what are the different database constraints in a PostgreSQL. We have primary key, foreign key, not null, unique, check. So these are all the constraints in a database. So in the next video, I'll be explaining what are all these constraints with an example. So in that way, it would be easier to understand. So that's it for the video. If you have any doubts, please ask them in the comment section. Thank you for watching.